That was a lot of welding. I still need to find a plate for the bottom, and also drill a hole and weld in a barb for the fuel hose. But I need to see if I can find any more scraps. This is all the scraps I had. So need to go dumpster diving. I'm not sure if this rubber gasket is rated for fuel. This is an hydraulic filler cap, so we just have to wait and see. And also if this is flush straight enough for this to seal. But we're gonna do a pressure test or leak test on the tank. I haven't done that yet. Now we can put the air gun down here, but we also need some kind of safety device. I don't want to rupture the tank by adding too much fuel, so I need to make some kind of safety thing to indicate when there's enough pressure in this. This actually is a protection device, and this is soapy water. It's leaking around the gasket. That wasn't really too shocking. I might have to glue this filler neck in place, but nothing else seems to leak so far. I want to sandblast parts of this blower, especially inside this impeller housing. But the closest sandblaster for me is 400 kilometers away. And that's not an option right now. So I bought this thing. I have no idea if this would work. Obviously I don't have a large enough compressor to run this. But I just have to take my time. And the sun is finally back. It has been below the horizon since December sometime. So the days are starting to brighten up again, luckily. So the blast pot is modified. I have 2 air inlets, one for each air compressor. I have 2 compressors I want to use for this. One small and one smaller. They are both combined way too small to run this efficiently, but I have to try with what I have. So this is my setup for now. My neighbors probably think I'm crazy, but oh well. The blast tank, I have 2 lines hooked up to it. Should have 2 lines. One line from each air compressor. I will prioritize this area. If I get that blasted good, I'm probably happy. The rest is not that critical. So let's suit up and give it a go. Oh. That was miserable. It looks like I managed to contain the dust quite well. Hey, that's not bad. It's obviously not 100% blasted, but I've blasted all areas and concentrated on the places where the paint flaked off. Where it flaked, I blasted. I needed to get this area as clean as I could because I'm going to weld inside here. The neighbors might think I'm even more crazy, vacuuming snow. All evidence is removed. There is no way my wife will ever know that I've sandblasted in the front yard. That's the most important part. Oh. Vacuuming snow was probably not my smartest idea. So the project now is to weld stainless steel inlay into this impeller housing. I have this water heater, so I will cut a strip out of this. Oh. Oh. Oh, that hurt. A spark got underneath the glasses. Oh, that hurt. I'm not sure if I said it. I probably said that this is stainless. It's not stainless, it's magnetic, but it doesn't rust. So I have no idea what kind of metal it is, but it welds perfectly fine to carbon steel. So my concern now is that I'm out of shielding gas. So let's see how far we get. Yeah, you get the idea. Lots of welding. I don't bother filming everything. I ran out of shield gas yesterday. I replaced the gas bottle and got 3 tacks done before I ran out of wire. Okay, so for some reason I had a terrible time welding this. Normally this should go smooth, but I think there were some impurities left. There's a double layer of steel, especially here. I didn't get all that cleaned up, so the welds are not super pretty. I need to grind down these to make the impeller fit. So I have rough fitted the auger and impeller. I have ground down most of the weld, not all of it, but pretty much. And I have an even 2 mm clearance around the impeller and the housing. Roughly 2 mm I've measured, and that's consistent all the way around. So I need to weld, come on, these three in a really awkward manner with TIG, and I'm not very good with TIG welding. So I'm not really sure how this will go, but we'll just have to try. This is my dad's welder. I haven't used this in a very long time. So let's see if I can remember. The finish might be a bit rough. I have no idea what I'm doing right now, so let's just try. Wow, that went way better than expected. Need more light. Alright, let's see if we can get just as lucky on this one. I just need to tack these, and then I can remove the tank to fully weld everything. So this junction box will be for well, wiring. For a future project I'm having an Arduino to control the engine, and it will also serve as a junction box for the control cable and everything else. So the plan is to mount it somewhere here, as high up as possible basically. Maybe something like that. So this is a DC current sensing relay. The plan with this was to have this to stop the actuator when there's enough tension on the belts. This is programmable. I can program it to shut off at any current level that I desire. But the problem is that the friction inside here varies, and this motor is way too strong. It can push 50 kilos. So the problem is that I cannot get the settings correct. If I set them too low, the actuator will stop prematurely, and it's just too strong and powerful to be able to use this. I'll demonstrate here. So 1.8, 1.6, it starts off at 1.8 amps and drops to 1.5 when retracting, and when engaging, now it started at only 1.2, went up to 1.7, but that varies. It's not very consistent. It will vary even more when this is cold, and the grease is cold, the belts are cold, and everything else. So I cannot use that. I tried explaining this yesterday, but I'm not sure if anything made sense. This is the actuator that is supposed to tighten the belts and start the impeller. The problem is the way it's mounted is that at full stroke it tightens the belt too much. This only has limit switches on the extreme ends, fully closed and fully open. My plan was to use this relay board. It's a DC current sensing relay. So I was planning to use this to cut power to the actuator when the belt started to get tight and the amperage increased in the motor. That would probably work, but the problem is that this actuator is too powerful. I need a significant amount of force on this before the amperage increases enough for this relay to trip. This is adjustable, but there is no significant difference between no load movement and the load needed, load at the desired stop, if that makes sense. The no load current will also increase when the grease inside here is cold and the belts are cold and everything, so it will not work. I got the connection to work, that's no problem, but it will not be a robust solution, so I can't use this. So I have to figure out something else. This took, I believe, 4 hours to figure out how to do. The bottom bracket for the actuator is now hinged with a spring. This bolt is not the permanent one, it's just what I had. So my thought here is that when the belt gets tensioned enough, this spring will start to compress. That will also create an, let's call it an auto tensioner. When these belts wear down, they stretch, become longer, and because of this spring, the tension will always be the same. So everything is just tacked together now, but it is strong enough to test. That's fully extended. And this is, I think this is good enough. Yeah, this is way tighter than on my other snowblower, so I'm pretty pleased with that. First bolt is down.